kind of the reverse variation of yesterday's problem which we saw. In this approach number 2, its reverse variation is the same problem which we are seeing today. It says that find the valid matrix given the row and the column sums. Just to be more precise, it says that you have a matrix which you have to build by yourself. Instead, what they have given is they have given you a row sum, they have given you a column sum vector. From this row sum and column sum vector, you have to build any such valid matrix which satisfies this condition. What I mean by row sum, it simply means if I do a summation of this entire row, it should match with this specific row sum value. If I do a summation of this entire column, it should match with this specific column value. This is what I have to make sure and thus build a matrix. Now, this is ultimately what is given to us. We'll go into example a little bit in a little bit time, but before that, in these kind of problems, don't get lost into all the possible or in what all possible things I can think of. No, just think of in perspective of one element. Always make a problem small. That you have, just imagine one row sum and one column sum. Now again, always increase your complexity little by little. Let's say you would have given an array of, let's say you have to build an array of size 1 cross 1. You are given the row sum, you are given the column sum. What could have happened? Obviously, the thing which could have happened is that this specific sum, let's say this is 3. Is this possible to be 2? No, obviously not. It should be also 3, so that 3 will be the actual matrix. Again, this is the matrix, this is the column sum, this is the row sum. Thus, one thing you realize that no matter what, row sum and column sum should be same. I'm not saying that at the index ultimately should be same. What I mean by ultimately, again, increase your size. See, I'm not doing anything. I'm just trying to see what all answers I can get. I'm just trying to think of that. So let's take again. Let's say again, row sum is given to you and column sum is also given to you. In this scenario, okay, row sum was 4. Now, with this scenario, you also need to know, again, this is, we are building the problem itself and then we are building the answer also for the same. Now, here let's say it has 3, but here it needs to be 1, because if let's say I have a value 4, if I bifurcate that value, basically I split that value to some values, it should ultimately match this. Or even if I put it exactly like this, 3 1, so this will exactly match my row sum. Thus, you will see it is given in the constraints itself that row sum should be equal to your column sum. And that is the condition. Row sum should be equal to a column sum. Now again, so you see that what we did here, again, this is what we're just building right here. Let's go on a bit more deeper. Okay, here it was 3 4. I just want to place some element here, but I also want to place some element such that my, like my effort goes down. So I will try, okay, I know that in this entire row, I need to place elements such that their sum should be equal to 3. Now, why should I not just even try to place 3 at the first place? Okay, I will place 3 at the first place itself, entirely 3. And I will say, okay, remaining are, let's say, 0. So you see, this condition is valid. But you will say, Aryan, what about the column condition? Oh yeah, it has become invalid. So in that scenario, just put a 1 to satisfy your column condition. Okay, that's also valid. But then you will go on to the next row. You will say, Aryan, it should be 8. Yeah, it is not 8. So put a 7 here. And then it also validated this remaining column. So the second catch here to understand is that as you were trying to place element and you were trying to just say, okay, this row is done, this column is done, next row is done, ultimately next column, which means the last remaining column, will also automatically be done. So again, let's see what we did. We have 5, we have 8. Okay, just simply try to balance your one row out. Okay, one row is done, 5. Now you might say, okay, Aryan, for this row, I'll just keep remaining as zeros. Okay, obviously. Then you have 7. Make sure, as you placed a 5, now your remaining target for this column is a 3, right? So now you had placed a 7. So can you place entirely a 7 here? Obviously not, because if you placed a 7 here, this you had to make a 3, but now you like ultimately you have to place a 3 here only. Like max to max, you can place a 3. That's the condition. but you are placing a 7. So make sure to satisfy both the conditions. So this column and this column, whosoever is not satisfied yet. So I will only have to place a 3 here. So this became a 0, which means this is gone. This is done. This is done. But because I placed a 3 here, this row now needs only a 4. Okay, now look for it again. That okay, place a 4 entirely because 6 is there which can handle. So this 4 is also gone. Now this 6 only needs to handle 2. So you see, we are just handling one row at a time. Okay, this row is done, I'm good. Because ultimately we know, ultimately if I handle every row, remaining one will automatically be handled because of some condition, some SUM condition, right? Now again, because this row is done, place a 0, 0 only. Okay, then next row, 9. Obviously I cannot place 9 here, so place it as 0. Here, okay, I can obviously place a 2. I have to place a 2 because I have to balance my second column. I placed a 2. Then ultimately you will see the remaining will be 7. The remaining will be 7. Did I do something wrong? 8, 6, 8, 5, 7, 10. Okay, this is 10. So here remaining will be 8. Remaining will be 8. And as you can see, automatically 8 will be satisfied. Now, if you are just confused, okay, Aryan, why is that the case? Why automatically it is satisfied? You can simply see that if I have something like this, and again, let's say if I just place a value, let's say 3 I have placed here. So ultimately what I'm doing is 1 I'm placing its corresponding, again, remaining thing, because this thing, this row is done, this row is entirely done. So I have to not place anything down, but because of to satisfy the column, I have to, let's say, place the remaining element down. Same way for this, as 1 is done, so I will place a 2 here in the next column, and because 2 is here, next remaining will be 2. Same way 2 is done, so I will place a 1 here and the remaining will be 3. So this is a condition up till you have consumed all of this. So you can see that this summation will be 9 and this entire summation will be 12. Now, as soon as you will place the last element, that last element, here let's say I placed a 4. So obviously I will have to place a 1 here. I will have to place a 1 here, and that is the condition that if 3 is occupied, 1 will be the one which is satisfying your answer. And same way, just to represent in the picture diagram as in the variable terms, you know this portion is R1 plus R2 plus R3. This entire portion was C1 plus C2 plus C3, considering that you can simply know that this, as I told you earlier also. Now what you did, simply you have to make sure that last row and last columns are also consumed, because R4 and C4 are not consumed yet. So as soon as you will say R4 should be consumed, so this is R4 which needs to be there, and this is the corresponding C4. And you also know that this entire thing, which after this R4 being consumed and this C4 being consumed, this will be R1 plus R2 plus R3 plus R4, and this thing also will be C1 plus C2 plus C3 plus C4, and we know both are same, thus our answer will always be valid. Cool. So that's the only thing what we have to do. Let's quickly see the code. It's exactly same what we did in the code itself. If I just show you a quick glimpse of the code, then it simply does the exact same stuff. Let's copy paste this entire stuff down, and so that I can just try it with the help of code with you guys. So what happened? I just went on and figured out the answer vector size. If this is size 3, if this is size 3, so vector size should be 3 cross 3. I built that vector specifically, and again by default I place as 0. If you want, you can keep it empty also, because this thing you are handling here. Now I went on to all the rows and columns. So firstly I went on to the first row. I checked minimum. Let's erase this. Then I checked minimum between 5. Then I checked minimum between 5 and 8. So minimum will be, that's the thing I hid in this tablet. The minimum is 5 and 8. Okay, I have to place a 5 here. Then this portion should go to 0, so that I know that as soon as I move on to the next column, I will place minimum of this and this. Again, this also should be reduced and it should become a 3. But I can only place 0, minimum of 0 and 6, minimum of 0 and 8, 0. Next time I placed 7 or 3, minimum, place a 3. Then after placing a 3, this will become a 4, because it has to also get some remaining value. Then 4 and 6, again it will place a 4 and this will become a 2. So this will become a 0 after placing a 4. Then 0 and 8, again a 0. Again, next time, here it has become a 0. So 0 and 10, 0. 0 and 2, sorry, 2 and 10, 2. This will become a 0. This became a 8 because of 2. Then 8 and 8, ultimately, I can place a 8 and then both becomes 0. And thus, this will be my matrix. So same way, I just got my answer of ij. This will be minimum of row sum of I and row sum of j. Also make sure to minimize both of them with the corresponding answer you have achieved right now and ultimately return your answer. Because of this traversal, you are ultimately taking O of n to m time because of iterating on all the, just to make the matrix itself, and space is O because of no extra space used. Now, people are always confused on Aryan. I got to know it. I clearly understood it, but I was not able to think it. And there's a high chance 1 year down the line, I'm still not able to think about it. So always in these scenarios, make sure one thing. If you have anything that you have to build something, there are two possible scenarios. Either you can try off with every possible scenario, which is simply saying recursion and backtracking. But as you know, recursion and backtracking takes a lot of time in terms of exponential. If that is not valid on your constraints, then the only way remaining is to go greedily. Finish first thing first, then go on to next thing and try to manage next thing according to the current state. So I finished my first row first, and then again, you see, I was completing my task one at a time. I was finishing my first row, then second row, then third row. So at least one thing was being finished. Remaining thing will automatically adjust in the end. That is the trick in these kind of problems. Cool. I hope you guys got it and you will remember it. Bye bye. Take care. Do join Twitter. We're gonna post some fire content there. Or okay, you can just go and check it out. I'll link in the description. Bye bye.